Math water bottle wastage in JBS. So today, I'm going to talk about the water bottle wastage in Dubai schools. The statement of inquiry. Through number changes, we find various quantities and representations which allow us to explore the ways in which humans adapt the environment. The inquiry question. Is JBS creating too much waste, and is there a solution? I will also be answering the following questions. How long will it take to fill up the new landfill with only bottles used from Dubai schools? And how many water bottles do all schools use per year? With the Al Khusais landfill reaching its maximum capacity, a new landfill called Al Layan 2 is being opened. The new landfill will have a length and width of 2 kilometers and an assumed height of 100 meters. I converted the 2 kilometers into 2,000 meters so that I would be working in the same units. So to find out how many disposable water bottles are wasted in JBS, I conducted a survey and found out that 67% of students bring their own water from home, while 33% buy from school. I also found out that 81% of students do not buy water bottles to flip them, whilst 19% actually do. Assumptions. So most of my assumptions were based off of the student and teacher similarities that I used in my calculations, and the fact that they were based off of JBS's data. I also spoke a little bit about the bottle flipping craze that was happening in JBS, as it has become such a great hit that approximately 19% of the students in JBS buy water bottles just for flipping them. I also took the assumption that 30% of the teachers use disposable water bottles. So, degree of accuracy. My degree of accuracy was significant figures, mostly 2, 3, and 4 significant figures rounding my calculations. I did think that this would give me a more accurate answer, and it would round all my answers to a whole number and to the same units. Also, some speaking about inverses out. Inverses out is when you have a number go into an equation without any decimal places. It has to come out of the equation without any decimal places as well. So JWB stands for water bottles in JBS, and WB is just water bottles. There are 896 students total in JBS and 113 teachers in JBS. In my survey, 33% of students said that they buy disposable water bottles, so I decided to do that for all students. And I assumed that 30% of all teachers buy disposable water bottles. So the number of water bottles in JBS per day is 406. Since there are 896 students in JBS, I found 33%, which is 295.68, or 296 to 3 significant figures. There are also 113 teachers, so I found 30%, which is 33.9, or 34 to 2 significant figures. S plus T equals students plus teachers. So I added together the teachers and students results, 34 and 296, to get 330. I then have the amount of water bottles divided by the students plus teachers, which is 406 divided by 330, which equals 1.23. So 1.23 equals the average number a person at JBS drinks in one day. There are 5 days in one school week, and there are 175 days in 1 year. D footnote W stands for days in 1 week. D footnote Y stands for days in 1 year. AJ footnote W stands for average number a person at JBS drinks per week, and AJ footnote Y stands for average number a person at JBS drinks per year. These are just you understanding my symbols. The average number a person at JBS drinks per week is the average number a person at JBS drinks in 1 day multiplied by 5, which equals 6.15. I'm now going to do upper and lower bounds to find the percentage error. Depending on what you're rounding to, the upper and lower bounds can either be the highest possible amount that the the original number can round to, or the lowest possible amount. The formula for this is big minus small divided by original times 100. So 6.10 is less than 6.15, which is less than 6.20. The upper bound is 6.20, the lower bound is 6.10, and the original is 6.15. Now put this into the formula, and I should get my answer, which is a 1.62% error. The average number a person at JBS drinks per year is the average number a person at JBS drinks in one day multiplied by 175, which is 1.23 times 175, which is 215.25. So here's the working out of the total amount of students in all schools in Dubai. After some research, I found out that there was 243,715 students in Dubai in 2013/14 in academic years. I then found out that it was predicted that there will be an annual 4.1% increase in the amount of students. I worked out how much it was until 2016 and 2017, continuously increasing each number by 4.1%. I then found out approximately how much it was going to be in 2016 and 2017. The final result was 274,937.8 students in all of Dubai. I did the same process as for students as teachers. So in 2013 and 14, I found out that there were 26,209 teachers in all of Dubai. So I decided to use the same increase rate for students as for teachers. So I increased it by 4.1% 3 more times until 2016 and 17, where I got 29,566.69. This is the approximate total of teachers in Dubai in 2016/17. NTSD is the number of teachers in all schools in Dubai. NSSD is the number of students in all schools in Dubai. The number of teachers in Dubai is 29,566.69, and the number of students in Dubai is 274,937.8. Since I'm using the data that I collected from JBS, I am going to use the same percentage to find out the amount of students and teachers in all Dubai that throw away its disposable water bottles. So 30% of 29,566.69 is 8,870.007, and 33% of 274,937.8 is 90,729.474. Now, I'm going to add these two amounts together, which is 99,599.481. This is the students and teachers that use disposable water bottles. When multiplied with 215.25, you get the total amount of students and teachers that use disposable waters per annum. This equals 21,438,788.29. This is all of the water bottles in all Dubai schools per annum. So I begin with taking the size of the water bottle, which is 330 milliliters, and convert it into cubic meters, which is 0.00033 cubic meters. I then multiply that by 21,438,788.29, which equals 7,074.800134. The volume of the landfill. The landfill is a cuboid, which means I need to find the volume of a cuboid. The formula is length times width times height. So I need to find 2,000 meters times 2,000 meters times 100 meters. So the volume of the landfill is 400 million cubic meters. 400 million cubic meters divided by the amount of space that each water bottle takes, which equals 56,538.69967. So 56,540 years to 4 significant figures. To fill up the entire landfill with bottles only from Dubai schools, it would equal 56,540 years. Now convert that into centuries would be 565.4 years. The way you get this is by dividing by 100. which equals 565.4 centuries. So to answer the inquirer question, is JPS creating too much waste and is there a solution? Well, I suppose, but what really is too much waste nowadays? We waste a whole lot every day, so how do you know when it's too much? Let's not get to that point and start now. Simple things in our daily lives can help. For example, recycling your water bottles and reduce the waste being thrown out. Maybe even go as far as discontinuing the distribution of plastic bottles in school and instead use reusable and sustainable ones. That's just a couple of things you can do to prevent waste. There is so much more. Limitations. So in my limitations, I stated the barriers I had during this investigation. For example, the websites that I used could not have been accurate or as reliable as I hoped them to be. Even as much as I checked them out, make sure that they were as accurate as possible. And as well, none of my calculations were perfect. I did not have perfect data, as it could vary in different schools on different days in different years. These all have factors in my limitations and barriers from getting a perfect accurate answer, which I do not have. So bibliography. In my first website, I gave it an 8 out of 8 because it was reliable and accurate and had well-known facts for the UAE. For my second website, I also gave it an 8 out of 8 because it was an extremely well-educated assumptions and statistics. For my third and fourth, I gave it a 4 and a 6 because they were inaccurate and unreliable, and there were some that statistics did show, but there were no dates on it.